Hello everyone, and welcome back to the Biochemistry SI Program YouTube channel. My name is Jess, and I'm one of your content creators this semester. So today we're going to talk about all things hydropathy plots, and specifically what you need in order to solve a problem that you might encounter on an exam. So what exactly is a hydropathy plot? Well, a hydropathy plot is going to measure our hydropathy index, and it's going to measure the number of amino acid residues in a singular protein. What a hydropathy index does is it measures our free energy change associated with the movement of amino acid side chains from a hydrophobic environment to a hydrophilic environment. So when you see these graphs, you should immediately start to think of transmembrane protein. This is what a transmembrane protein looks like. Notice how it spans across the entire membrane. The amino acids inside the membrane are going to be hydrophobic, and the amino acids found outside of the membrane are going to be hydrophilic. So it's going to take about 20 amino acids in order to cross our membrane. So let's think about how you would solve a problem like this. First, we're going to need to know how to read our hydropathy plot. Make sure we understand that our positive free energy values are going to be associated with our hydrophobic amino acids, aka our amino acids found inside of the membrane. These are our negative hydropathy values. These are going to be associated with our hydrophilic amino acids, and they'll be found outside of our membrane. Let's take a look at an example of a protein. Notice how this protein crosses our membrane once, so it's a transmembrane protein. Since it crosses once, we can see that our hydropathy plot would look something like this. Notice how there is one positive peak. Again, notice how it crosses once. Let's say that our N-terminus is located on the outside or extracellular membrane or luminal face of the membrane. These are all different ways to say outside of the membrane. We would know that our C-terminus would have to be found on the inner membrane, or you can hear the words inner leaflet of the membrane. These mean the same thing. So let's look at a hydropathy plot. Notice how there are 4 positive peaks in our graph. So we're looking at a protein that's going to cross our membrane 4 different times. Now let's consider a question that could be asked based on this hydropathy plot. Consider the hydropathy plot for a transmembrane protein with its amino terminus located on the inner leaflet of the plasma membrane. Where is its carboxy terminus located? So let's walk through how I would solve this problem. So I'm going to set up my hydropathy plot here based on the question that was asked. I was told that the amino terminus is on the inner leaflet, so I will draw it like so. Now I know for each positive spike in my graph, I am crossing the membrane to another side. So for my first cross, if I start on the inside, I am going to end up on the outside. For my second cross, I come back into the inside. So for my third cross, we head back to the outer leaflet, and for the fourth cross, we know that our carboxy terminus must be in the inner leaflet of the membrane since our protein ends. If that didn't make sense, take a look at this protein and notice the 4 transmembrane segments. This protein is exactly what we just demonstrated from our hydropathy plot, so make sure that this makes sense to you, and if not, try to go back and redo the question. I encourage you to quiz yourself on these problems to make sure that you aren't just blatantly following along. For example, you should be able to answer the question, what would happen if our protein had only 3 transmembrane segments? Or what would happen if our carboxy terminus was located on the outer leaflet of the membrane? And what kind of amino acids would be found there? These are the kind of questions you should be able to answer in order to master the concept. As usual, I encourage you to join the Campus Wire and go to office hours. Dr. Alman also has an additional video on hydropathy plots if you still need more help. Thanks for watching, and we look forward to seeing you in the next video.